Well, we're having a look at solution of equations of the form sine nx equals cos of nx. Now, these are really tan questions in disguise. And the technique that you use is really very clever, and I'll show you as we go. Now, let's have an example here. We've got solve the equation sine 2x equals cos 2x for x in the domain of 0 to 2 pi inclusive. Okay, so this is the thing. First of all, you've got to work out, well, I always work out my working domain. And of course you've got x goes from 0 to 2 pi, therefore what would 2x go for? Because that's what we're considering in this equation. So therefore we know that 2x must go from 0 to 4 pi. So I'm going to use that in capturing my solutions. Now, this is the beautiful technique. You look at that expression, and originally when you look at it you think, good heavens, how can I work this out? I've got sine and I've got cos. I'm not sure. But if you just divide both sides by cos of 2x, look what happens. Oh, now that is a infinitely simpler kettle of fish. So, now we've got just one trig term, we're back in control. So, let's dig our cast diagram out and work out which quadrants we want, and it's those two quadrants for positive tan. And what is our basic angle? Our basic angle, which has a tangent of 1 in quadrant 1, is pi on 4. So all we've got to do now is basically say that therefore our 2x equals pi on 4 from quadrant 1, 5 pi on 4 from quadrant 3, and then just keep adding pi to each term because tan has a period of pi. So each solution will be pi more than the last one. I think my little helper just wanted to tell me that. Yeah, thank you, little helper. That's great. Okay, that's what we're going to do. There we go, there we go. Now we've got to watch till when we get out of range. Ooh, I think we're out of range. 17 pi on 4 is out of range because 4 pi is 16 pi on 4. Okay, so I divided by 2, and that's what I got. Divided by 2, and that's what x is. That is the solution of that equation, sine 2x equals cos 2x, where x goes from 0 to 2 pi. Pretty neat, huh? Okay, now we'll just see what we've got to do now. This next question says we're on the same set of axes, we've got to sketch the graphs of y equals sine x and y equals cos x from x going from 0 to 2 pi inclusive, and we've got to find the coordinates of the points of intersection. Well, I'm okay with sketching sine x, and yes, I'm okay with sketching cos x, but the trap with this question is they want us to find the coordinates of the points of intersection, and unless they say two decimal places or something decimally, we are required to give our answer in exact form. So in actual fact, we have to solve this question for when sine x and cos x have the same value, e.g. intersect. So that is another tan question in disguise. Okay, at the intersection points, sine x equals cos x, yes, we were just discussing that, and we need exact coordinates. That's exactly what we need at the points of intersection. So therefore, we're saying that sine x equals cos x. Therefore, using our technique where we divide both sides by cos, we get tan x equals 1. Well, that's, again, beautifully simple. And we know that, yes, we need, the quadrants we need are 1 and 3, quadrant 1 and 3, and the basic angle, which has a tangent of 1, is pi on 4. That's what it is. Okay, now, here we go. Now, between 0 and 2 pi, we don't have to do a working domain because this whole equation was just written in terms of x, not some other variant of x. So, yeah, so we just go from 0 to 2 pi, and we know that when x is pi on 4, sine x and cos x both have a value of 1 over root 2. And when x is pi over 4, we know that sine x and cos x have exactly negative 1 over root 2, because you can figure that out from the cast diagram, because in that quadrant the only one that's positive is tan. Oh, wow, that was pretty easy, wasn't it? So now we've got to get our coordinate points. They asked for coordinate points, so that's what they mean. Now let's go for the graph, and we'll put all our information in. There's sine x, there's cos x, and now I think I have to put in my I want to put my x-intercepts in as coordinate points, because I'm fairly paranoid about that. Unless they just ask for intercepts, you have to basically put the points in. A point means open bracket x comma y, close bracket. Now we're going to put our intersection points in. There's the first one, and there's the second one. Gee willikers, that's good, isn't it? Oh, gee, maths is marvellous. Alright, now here's another one for us. What's this one say? Oh, another tanny one in disguise. Working domain required, because we've got 3x and not just x. And let's go for it. I think this will be easy now. So, if x goes from minus pi to pi, then 3x has to go from minus 3 pi to 3 pi, okay? Now, that's our working domain. Yes, it is. Now, we're going to divide both sides by cos 3x to get our wonderful tan 3x term, and we're saying that that equals 1 over root 3. Now, you've got to start thinking, what angle am I talking about here, and what quadrants do I want? Well, the basic angle in quadrant 1 is pi on 6. And there's our cast diagram. So, which quadrants? Yeah, that's the ones. They're the ones. Now, I think we have to go backwards as well as forwards in this question, because we're going from minus 3 pi to plus 3 pi. So let's go forwards first from 0 up to 3 pi and capture all the solutions from our cast diagram as we whiz around. Oh, I'm going to do the negative ones, aren't I? That's the negative ones, sorry. Yeah. Now, do you see how I did that? I went from 0. The first one I captured was in the negative direction, minus 5 pi on 6. Then I was almost around in the negative by 2 pi, but it was not quite, minus 11 pi on 6. And then you just keep adding pi to each value, and until you're out of range. Now, one of them is out of range, I think. Yeah, we've got to go to minus 3 pi, which would be 18 pi on 6, wouldn't it? Yes. Goodbye. We don't want you. No offence. And now we're going to go round in the positive direction from 0 upwards. There we go. As easy as pie. Pardon the pun. Right. So now are we out of range? Yes, we are. We're out of range. Goodbye, Mr. 19 pi on 6. You're gone. Now, what I now do is I line them all up from the very smallest, most negative, in order up to the very largest, most positive, like ducks in a row. There we go, there we go, and there we go, and there we go. Now, all we've got to do is solve it for x, which means we just have to divide by 3. Ah, ain't it easy, ain't it easy. There you go. It's just so simple, isn't it, when you know how? Oh, there's Smiley. Hello, Smiley. What do you think about all this? Yes, it's very cool. And so are you, Smiley. And so are all you students watching this too. Okay, I'm going to go now and have a nice cup of tea. See you.